with Newtonian physics. They worked it all out by assuming they could just accelerate faster and faster and the speed of light wasn't an issue. They don't know about time dilation. Rocky doesn't realize that Arid experienced a whole bunch more time than he did on that trip. They don't know about length dilation. The distance to Tau Ceti will actually increase as you slow down relative to it, even if you're still going toward it. An entire planet of intelligent people put together a ship based on incorrect scientific assumptions, and by some miracle, the sole survivor of the crew was clever enough at trial and error problem solving to actually get it to its destination. And out of that major screw-up comes my salvation. They thought they'd need a whole lot more fuel, so Rocky has boatloads to spare. Okay, Rocky, I say. Get comfortable. I have a lot of science to explain. He knocked twice and leaned into my office. Dr. Grace? Are you Dr. Grace? It wasn't a large office, but you're lucky to have any personal space at all on an aircraft carrier. Before it held the high honor of being my office, the room was a storage locker for bathroom supplies. The crew had 3,000 butts that needed daily wiping. I got to keep the room as my office until the next time we were in port, then they'd fill it up with more supplies. I was approximately as critical as toilet paper. I looked up from my laptop. The short, somewhat disheveled man at the door waved awkwardly. "Yeah," I said. "I'm Grace. You are—" "Hatch, Steve Hatch, University of British Columbia. Nice to meet you." I gestured to the folding chair in front of the folding table I used as a desk. He shuffled in carrying a bulbous metal object. I'd never seen anything like it. He plunked it on my table. I looked at the object. It was like someone had flattened a medicine ball, added a triangle to one end and a trapezoid to the other. He sat in the chair and stretched his arms. "Man, that was weird. I've never been on a helicopter before. Have you?" "Well, of course you have. How else would you get here? I mean, I guess you could have used a boat, but probably not. I hear they keep the carrier far away from land in case there's a disaster during astrophage experiments. A boat would have been nicer, honestly. That helicopter ride almost made me puke, but I'm not complaining. I'm just happy to be involved." I gestured to the object on my desk. "What is this thing?" He somehow became even more energetic. "Ah, right. That's a Beetle. Well, a prototype for one anyway. My team and I think we have most of the kinks worked out. Well, you never have all the kinks worked out, but we're ready for actual engine tests. And the university said we had to do those here on the carrier. Also, the provincial government of British Columbia said it. Oh, and the national government of Canada said it too. I'm Canadian, by the way, but don't worry. I'm not one of those anti-American Canadians. I think you guys are all right." "Beetle?" "Yeah." He picked it up and turned the trapezoid toward me. "This is how the Hail Mary crew will send us back the information. It's a little self-contained spacecraft that will automatically navigate itself back to Earth from Tau Ceti. Well, from anywhere, really. That's what me and my team have been working on for the past year." I peeked into the trapezoid to see a shiny glass-like surface. "Is that a spin drive?" I asked. "Sure is. Man, those Russians know their stuff. We just used their designs and everything came out great. At least I think it did. We haven't tested the spin drive yet. The tricky part is navigation and steering." He turned the device around and faced the triangular head toward me. "This is where the cameras and computer are. No fancy schmancy inertial navigation nonsense. It uses ordinary visible light to see the stars. It identifies constellations and works out its orientation from that." He tapped the center of the bulbous carapace. "There's a little DC generator in here. As long as we have astrophage, we have power." "What can it carry?" I asked. "Data. It's got a redundant RAID array with more memory storage than anyone would ever need." He knocked on the dome. It echoed slightly. "The bulk of this puppy is fuel storage. It'll need about 125 kilos of astrophage to make the trip. Seems like a lot, but man, 12 light years." I lifted the device and hefted it in my hands a couple of times. "How does it turn?" "Reaction wheels inside," he said. "It spins them one way, the ship turns the other, easy peasy." "Interstellar navigation is easy peasy?" I smiled. He snickered. Well, for what we have to do, yeah. It has a receiver that's constantly listening for a signal from Earth. Once it hears that signal, it'll broadcast its location and await instructions from the Deep Space Network. We don't have to be super accurate with the navigation. We just need it to show up within radio range of Earth. Anywhere within the orbit of Saturn or so will do just fine. I nod. And then scientists can tell it exactly how to get back. Clever. He shrugged. They'll probably do that, yeah, but they don't need to. They'll have it radio over all the data first thing. The information gets across, then they can collect it later if they want. Oh, and we're making 4 of these. All we need is for one of them to survive the trip. I turned the Beetle this way and that. It was surprisingly light, a few pounds at most. Okay, so there are 4 of these. How likely is each one to survive the trip? Is there at least a little system redundancy aboard? He shrugged. Not that much, no, but it doesn't have to travel for nearly as long as the Hail Mary does, so stuff doesn't have to survive as long. It's going the same route, right? I asked. Why doesn't it take the same time? Because the Hail Mary's acceleration is limited by the soft, squishy humans inside. The Beetle doesn't have that problem. Everything aboard is military-grade cruise missile electronics and parts that can handle hundreds of Gs of force, so it gets to relativistic speed much faster. Oh, interesting. I wondered if this would make a good question for my students. I dismissed the idea immediately. It was absurdly complicated math no 8th grader would be able to handle. Yeah, Hatch said. They accelerate at 500 Gs until they reach a cruising speed of 0.93 C. It'll take over 12 years to get back to Earth, but all told, the little guys will only experience about 20 months. Do you believe in God? I know it's a personal question. I do. And I think he was pretty awesome to make relativity a thing, don't you? The faster you go, the less time you experience. It's like he's inviting us to explore the universe, you know? He fell silent and stared at me. Well, I said, this is really impressive. Good work. Thanks, he said. So can I have some astrophage to test it? Sure, I said. How much do you want? How about 100 milligrams? I drew back. Easy there, cowboy. That's a lot of energy. All right. Can't blame a guy for trying. How about 1 milligram? Yep, I can swing that. He clapped. Hell yeah. Astrophage coming my way. He leaned forward to me. Isn't it amazing? Astrophage? I mean, it's like the coolest thing ever. Again, God's just handing us the future. Cool, I said. It's an extinction-level event. If anything, God's handing us the apocalypse. He shrugged. I mean, maybe a little, but man, perfect energy storage. Imagine a battery-powered household. Like, you have a AA battery but full of astrophage. That'd last your house about 100,000 years. Imagine buying a car and never having to charge it up. The entire concept of power grids is going to end. And it'll all be clean, renewable energy once we start breeding this stuff on the moon or something. All it needs is sunlight. Clean? Renewable? I said. Are you suggesting astrophage will be good for the environment? Because it won't be. Even if Hail Mary finds a solution, we're looking at a mass extinction. 20 years from now, a whole bunch of species on Earth will be extinct. And we're working hard to make sure humans aren't one of them. He waved off my comment. Earth's had 5 mass extinction events in the past, and humans are clever. We'll pull through. We'll starve, I said. Billions of people are going to starve. Nah, he said. We're already stockpiling food. We got a bunch of methane in the air to hold in the solar energy. It'll be all right. As long as Hail Mary succeeds. I just stared at him for a moment. You are, without a doubt, the most optimistic person I've ever met. He gave me a double thumbs up. Thanks. He picked up the Beetle and turned to leave. Come on, Pete, let's get you some astrophage. Pete? I asked. He looked over his shoulder. Sure. I'm naming them after the Beatles, the British rock group. I take it you're a fan. He turned back to face me. Fan? Oh, yes. I don't want to exaggerate, but Sgt. Pepper's Lonely Hearts Club Band is the greatest musical accomplishment in the history of mankind. I know. Many would disagree, but they're wrong. Fair enough, I said. But why Pete? Aren't the Beatles named John, Paul, George, and Ringo? Sure, and that's what we'll call the ones aboard the Hail Mary, but this fella is for testing in low Earth orbit. I get a whole SpaceX launch just for me. Isn't that amazing? Anyway, I named him after Pete Best. He was the drummer for the Beatles before Ringo. Okay, I didn't know that, I said. Now you do. I'm going to get that astrophage now. I've got to make sure these Beatles will be able to get back. Okay? He frowned. Get back. It's a song. It's by the Beatles. Sure, okay. He spun on his heel and left. Some people got no appreciation for the classics. I was left confused in his wake. Pretty sure I wasn't the first. Chapter 19. Rocky was dumbfounded by relativity. For the first couple of hours, he simply refused to believe me. But then, as I showed more and more about how it explained his trip, he came around. He doesn't like it, but he accepts that the universe uses rules that are much more complicated than we can see. And since then, we've spent an eternity making chain. I made molds as fast as I could, and Rocky cranked out links as fast as Xenonite would set. It was a good system, one with a geometric progression of results. Every new mold I made added 1 to the number of links Rocky could make per batch. Chain, chain, chain. If I never see another chain again in my life, it will be too soon. 10 kilometers of chain, each link just 5 centimeters long. That's 200,000 links. Each one connected by hand or claw. It worked out to each of us working 8 hours per day for 2 weeks, doing nothing but connecting links. I saw chain whenever I closed my eyes. I dreamed of chain every night. One of my dinner packets was spaghetti, and all I could see were smooth white chains instead of noodles. But we got it done. Once we had all the links made, we assembled them in parallel. We both made 10-meter lengths that we linked into 20s and so on. At least we could be efficient that way. The tricky part was putting it all somewhere. 10 kilometers is a lot of chain. The lab ended up being sort of a holding area, and even then it just wasn't big enough. Rocky, ever the talented engineer, made large spools that could just barely fit through the airlock. With a whole bunch of EVAs, I mounted them to the hull. Then I stored the chain on them in 500-meter chunks. But of course, to do EVAs, I had to spin down the centrifuge, so everything from that point on was in 0G. Ever assemble chain in 0G? It's not fun. The final assembly of those 500-meter chunks was challenging, to say the least. I had to connect all 20 of them together while wearing my EVA suit. Fortunately, I had the manipulator device from the IVME. NASA didn't intend for it to be a chain-making tool, but that's what I used it for. Now, Rocky and I float in the control room. He's in his bulb, and I'm in my pilot's seat. Status of probe? I say. Rocky checks his readouts. Device is functioning. Rocky did a good job on the sampler probe. At least, I think he did. Engineering isn't my forte. The sampler is a steel sphere, 20 centimeters across. It has a nice thick ring on top that connects to the chain. Small holes perforate the sphere along its equator. They lead to a hollow inner chamber. There's a pressure sensor in there and a few actuators. The pressure sensor knows when the probe is at the right altitude and will trigger the actuator to seal off the chamber. It's a simple matter of rotating the inner chamber shell a few degrees to deliberately misalign the holes in the outer sphere. That misalignment, along with some well-placed gaskets, will seal the local air in the chamber. He also added a thermometer and heater in there. Once the sampler seals, the heater will maintain whatever temperature the air inside started at. Simple stuff, really, but I hadn't thought of it. Life can be pretty picky about temperature ranges. The only remaining piece is a small radio transmitter that broadcasts a weird analog signal I wasn't able to read or decode with my equipment. Apparently, it's a very standard Iridium data connection. But he has the receiver for it, and that's what matters. Just like that, with minimal complication, Rocky had made a life support system for Adrian life forms, a system that didn't need to know the conditions to provide in advance. It just maintains the status quo. He really is a genius. I wonder if all Iridians are like that, or if he's special. I guess we're ready, I say. I'm not exactly brimming with confidence.
Yes,
he quavers. I strap myself into the pilot's seat. He uses 3 of his hands to grip handholds in his bulb. I bring up the attitude control panel and initiate a roll. Once I have the ship pointed backward to our direction of travel and parallel to the ground below, I halt the rotation. Now we're hurtling along, butt first at 12 kilometers per second. I need that to be almost 0. Orientation is good, I say. Initiating thrust.
yes,
Says Rocky. He watches his readout screen intently. It shows him the textured version of my own screen thanks to that camera he set up earlier. Here goes. I fire up the spin drives. We go from 0G to 1.5 Gs in under a second. I am pressed back in my chair and Rocky grabs a support with a 4th hand to stay steady. As the Hail Mary slows down, our velocity can no longer keep us in orbit. I glance at the radar panel and it confirms that we are losing altitude. I adjust the ship's attitude so we are pointing very slightly upward from horizontal, just a fraction of a degree. Even that small amount is too much. The radar shows us gaining altitude rapidly. I bring the angle back down. This is a sloppy, nasty, horrible way to fly a spacecraft, but it's all I have. There was no point to calculating this maneuver in advance. There are so many variables and ways to mess up the math, I'd be flying on manual almost immediately anyway. After a few more overcorrections, I get the feel for it. I increase the angle bit by bit as the ship slows down with respect to the planet.
You tell when to release probe,
Rocky says. His claw hovers over the button that will eject the spools and let the chain fall freely. We can only hope it doesn't get tangled. Not yet, I say. The attitude screen shows we're at 9 degrees from the horizontal. I need to get us to 60. Something catches my eye off to the right. It's the external camera feed. The planet below is glowing. No, not the whole planet. Just the bit right behind us. It's the atmosphere reacting with the IR blast from the engines. The Hail Mary is dumping hundreds of thousands of times more energy into that spot than Tau Ceti does. The IR heats the air so much it ionizes, and it's literally red hot. The brightness increases as our angle gets more severe. Then the affected area starts to grow. I knew it would be significant, but I had no idea it would be like this. We're leaving a red streak across the sky, destroying anything in the air. The carbon dioxide is probably being ripped apart from pure heat energy into particulate carbon and free oxygen. The oxygen might not even be forming O2. That's a lot of heat. The engines are heating up Adrian's air a lot, I say.
How you know question?
Sometimes I can see heat.
What question? Why you no tell me this question?
It's related to sight. There's no time to explain it. Just trust me. We are making the atmosphere very hot.
Danger question?
I don't know.
I no like that response.
We angle up and up and up. The glow behind us gets brighter and brighter. Finally, we reach the correct angle. Angle achieved, I say.
Happy release question?
Stand by. Velocity? I check the navigation console. 127.5 meters per second, just what I calculated. Holy cow, it worked. I feel the pull of Adrian tugging me into my seat. This is one of those things I frequently have to explain to my students. Gravity doesn't just go away when you're in orbit. In fact, the gravity you experience in orbit is pretty much the same as you'd experience on the ground. The weightlessness that astronauts experience while in orbit comes from constantly falling. But the curvature of the Earth makes the ground go away at the same rate you fall, so you just fall forever. The Hail Mary isn't falling anymore. The engines hold us up in the sky and our tilt makes us scooch forward at 127 meters per second, about 285 miles per hour. Fast for a car, but amazingly slow for a spaceship. The air behind us glows so bright the external camera shuts down to protect its digitizer. The life support panel comes up on my main screen, unprompted. External temperature extreme, it warns. Air is hot, I call out. Ship is hot.
Ship no touch air,
Rocky says.
Why is ship hot question?
It's bouncing our IR back at us, and it's so hot now it emits its own IR. We're getting cooked.
You ship is astrophage cooled question?
Yes, astrophage cools ship. Astrophage conduits run all along the hull for just such an occasion. Well, not the occasion of blasting a planet's atmosphere with so much IR light the results can melt steel, but the general situations where heat builds up, mostly from the sun or Tau Ceti, heating the ship up and the heat having nowhere to go.
Astrophage absorb heat, we safe.
Agree, we safe. And we ready. Drop probe.
Drop probe.
He slams his claw on the drop button. I hear the scrape and clink of the spools sliding off the hull one at a time and falling toward the planet below. 20 spools in all. Each one drops and unwinds before the next is released. Our best effort at keeping the chain from getting tangled.
Spool 6 away,
Rocky reports. The life support panel blinks its warning again. I mute it again. Astrophage lives on stars. I'm sure a little reflected IR light won't be too much heat for it to handle.
Spool 12 away,
Rocky says.
Sampler signal good. Sampler detecting air now.
Good, I say.
Good,
he says.
Spool 18 away. Air density increase.
With the external cameras offline, I can't see any of what's going on, but Rocky's readings are right in line with our plan. Right now the chain is unfurling as it falls. Our angled engines keep us in the sky, but nothing keeps the chain from falling straight down.
Spool 20 away. All spools released. Air density of sampler is almost astrophage breeding ground level.
I watch Rocky with bated breath.
Sampler has closed. Seal is airtight. Heater is on. Success, success, success.
Success, I yell. It's working. It's actually working. We have a sample of Adrian air from the astrophage breeding zone. If there are any predators, they have to be there, right? I hope so. Step 2 now, I sigh. This is not going to be fun. I unhitch my restraints and climb out of the chair. Adrian's 1.4 Gs of gravity pulls me down at a 30-degree angle. The whole room feels tilted because, actually, it is tilted. This isn't engine thrust I'm feeling. It's gravity. 1.4 Gs isn't too bad. Everything's a bit harder, but not unreasonably so. I climb into the Orlan EVA suit. This is going to be difficult to say the least. I have to go outside and do an EVA while completely under the effects of gravity. Needless to say, absolutely no part of the EVA suit, the airlock, or my training was remotely designed for this possibility. Who would have thought I would have to tromp around on the ship in full gravity? More than full, in fact. Yet, however much gravity there may be, there's still no air. Worst of all worlds. But there's no other way. I have to get the sample. Right now, the sampler hangs at the end of a 10-kilometer chain, which is just dangling in the air. There's no easy way for us to get it back to the ship. When planning this all out, my first thought was to thrust away from the planet, then collect the sampler when we're back to 0G. Problem is, there's literally no way to do that without vaporizing the sampler. Any path I try to take to get the ship out of Adrian's gravity, or even into a stable orbit, will mean using the spin drives. They'd push the ship along, which would make the chain and sample lag behind us and into the IR blast behind the ship. And then the sampler, everything in it, and the chain all become individual, very hot atoms. The next idea I had was to make a huge spool that could winch up the chain, but Rocky informed me he'd never be able to make a spool big enough and strong enough to bring up the entire 10-kilometer length. Rocky had a pretty clever thought. The sampler could climb the chain when it was done, but after some experimenting, he ditched the idea. He said the risks just weren't worth it. So we have this other plan. I grab a special winch Rocky designed and attach it to my suit's tool belt.
Be careful,
says Rocky.
You are friend now.
Thanks, I say. You are friend also.
Thank.
I cycle the airlock and look outside. This is a strange experience. Space is black. The planet is majestic below me. Everything looks like it should when in orbit, but there's gravity. A red glow from the planet peeks out around the edges of the Hail Mary. I'm no dope. I oriented the ship to make sure it would shield me from the deadly heat bouncing up off the atmosphere. The airlock door is up. I have to pull myself and 100 pounds of gear up and through that opening, and I have to do it in 1.4 G. It takes me a full 5 minutes. I grunt. I say a bunch of not really profane things, but I get it done. Soon I'm standing on top of my ship. One misstep, and I'll fall to my death. I wouldn't have to wait long for it either. As soon as I fell below the ship, the engines would punch my ticket. I attach a tether to the handrail at my feet. Will a 0G tether save me if I fall? It's not mountain climbing gear. It wasn't made for this. Better than nothing, I guess. I walk along the hull toward the chain anchor point. It's a large xenonite square that Rocky made. He explained in great detail how to adhere it to the hull. Looks like it did the job just fine. The chain is still attached. I reach it and get down on my hands and knees. The gravity is absolutely brutal in this EVA suit. No part of this is how things are supposed to be. I hook my possibly worthless tether to the nearest handrail and pull the winch from my tool belt. The chain hangs away at a 30-degree angle and disappears into the planet below. It just goes so far away it's too thin for me to perceive after a kilometer or so, but I know from Rocky's readings it's the full 10 kilometers down, with a sample container full of potential salvation for 2 entire planets full of people. I wedge the winch between the chain and the anchor plate. The chain doesn't budge, not even a millimeter, but that was expected. There's just no way human muscle could move something that heavy. I hook the winch to the anchor plate. The casing of the winch is xenonite, so the xenonite to xenonite connection